homework solution 4.10. The generator has a speed droop characteristic of 1 megawatt per hertz and a no-load frequency of 61 hertz. What's the power supplied by the generator when connected to a 60 hertz infinite bus? How can the power supplied by the generator be decreased by 10%? So the givens here are that the droop characteristic of the generator is 1 megawatt per hertz. The initial gen set point is 61.0 hertz. We've got a electrical frequency of 60 hertz for this infinite bus, and we're asked to find P1, which is the power provided, and we want to know what the no-load frequency is to decrease the power by 10%. So the solution to infinite bus problems is that the house diagram gets modified a little bit. You still have two sides and two axes. The x-axis is still representative of real power, except on the right side we typically plot the power associated with the generator connected to the infinite bus. On the left side we plot the power of the infinite bus. The middle is still 0 megawatts or 0 kilowatts or whatever. The y-axis still represents electrical frequency. So that means the right-hand side of this plot looks the same as it always has. We have a slope characteristic of 1 megawatt per hertz in this example, and that intersecting point is the no-load frequency, right? It's the frequency at 0 megawatts, so that's 61.0 hertz right there. Now, an infinite bus, the property that's important of an infinite bus is that its frequency is constant. We were told that this infinite bus has 60 hertz frequency, and so a constant frequency would look like that right there. So the amount of power provided by this generator on this side of the diagram to this infinite bus is going to be wherever this line intersects with that right there. So the distance from here to here is the power provided by Gen 1. So this reduces down to the same math that was used in a single generator system, except now P is fixed at whatever the frequency of the infinite bus is. So this is P1 is equal to SP1 times F no load 1 minus F sys, and we've got that's equal to 1 megawatt per hertz times 61.0 minus 60.0. And so this guy is providing 1 megawatt of power into that infinite bus. So we're asked to that was part A. In part B, we're asked to decrease that by 10%. So P new is equal to 0.9 times P1, which is just 0.9 megawatts. And so we now just set our problem statement up to say 0.9 megawatts is how much power we want the generator to provide. That's equal to the slope of the droop characteristic, 1 megawatt per hertz. To change the amount of power of this generator is providing, this is what we adjust, the gen set point or the no load frequency. And again, it's an infinite bus, so the frequency is set at 60 hertz. And so we get a no load frequency of 60.9 hertz. We see that it was 61 hertz, so to decrease it, we needed to go down by 0.1 hertz. So decreasing the no load set point moves this line down, and therefore decreases the amount of real power that it will supply. So those are the power associated with the generator and the no load frequency.